So in this lesson, I'm going to review calculations using the concept of molarity. Now, just as a quick review, remember molarity, which is a measure of concentration, equals your moles of your solute, which is the substance that is being dissolved, divided by the volume in liters of your solution, which is your solute plus your solvent. Okay, so let's work on some practice problems. How many liters of a 0.88 molar solution can be made with 25.5 grams of lithium fluoride? Okay, so I know my concentration. My concentration is 0.88 molar. Okay. I know my grams of my solute, so I need to figure out what that is in moles. So to convert out of grams, I'm going to put grams on bottom, and I'm going to put moles up top. Remember, I'm going to have to use my molar mass here. So I first need to determine the formula for lithium fluoride. Lithium has a +1 charge. Fluoride has a 1- charge, so this will just be LiF. Okay. So then I'm going to look at the molar mass of lithium, which is 6.941, plus the molar mass of fluorine, which is 18.998. And I get the molar mass of lithium fluoride, which is 25.939. Okay, and that's that many grams per mole. So I'm going to take 25.5 and divide by the molar mass, and that will be my number of moles I plug in for the number of moles in my molarity formula. So 983. Okay, I'm going to keep this unrounded in my calculator though, and I'm solving for x. So keep in mind, when you've got a variable in the denominator, you need to cross multiply. So I have 0.88 times x. Now my x is out of my denominator, so it's going to be much easier to solve, and that equals 0.983. Okay, so to solve for x now, all you have to do is divide both sides by 0.88, okay, and you'll get your answer. Now keep in mind, if you kept the 0.983, etc., in your calculator, now you could just divide by 0.888 without having to plug anything else in, and you get your answer. Okay, so unrounded, it's 1.117. Okay, keep in mind, the molarity has 2 sig figs, mass has 3 sig figs, so I'm going to want 2 sig figs for my final answer. So it's going to be 1.1, and this is volume, so the units are going to be liters. All right, let's look at the next example. It says, what is the concentration of a solution? So it's asking me to determine the molarity with a volume of 660 mils that contains 33.4 grams of aluminum acetate. So really quickly, aluminum acetate. Aluminum has a 3+ charge. Okay. Acetate, C2H3O2 minus, is one of my polyatomic ions, and it has a 1- charge. So its formula, just to help me out, is going to be Al C2H3O2 with a subscript 3 on the outside, because I will have 3 acetates. Okay, so now remember molarity, which is what I'm solving for, equals your moles of your solute divided by your liters of solution. Okay, so for moles, I know I have 33.4 grams of my solute. I need to first get that into moles. So I'm going to get out of moles by putting grams on bottom and moles up top. I now need to determine the molar mass of aluminum acetate. So aluminum has a molar mass of 26.982. Carbon is 12.011, but I have 6 carbons because I've got a 2 here and a 3 here, so I've got a total of 6. Okay. Then I've got hydrogen, which is 1.008, but I have 9 of them, so I'm going to multiply by 9. And then I'm going to add to that oxygen, 15.999, but I have 6 of those. Okay, so the molar mass of aluminum acetate is going to be 204.114. Okay, so now I'm going to take 33.4, divide by 204, and I get I'm going to round it just a little bit, just so I'm not writing out a bunch of digits, 0.1636. Now I'm going to keep that unrounded in my calculator, and I'll use that in a minute. Okay, so my molarity, which is what I'm trying to solve for, equals my moles, 0.1636, but I'm going to use the unrounded value in my calculator, divided by my volume in liters. Well, my volume right now is 660 mils. I need that in liters. So you can either do it in your head by dividing by 1,000, or set this up. I'm going to get out of milliliters into liters. 1 milliliter is 10 to the negative third liters. Okay, so then that will give me 0.66 liters. Okay, so 0.66 liters on bottom. Okay, so I'm going to divide the 0.1636, but I kept the entire number in my calculator still. I'm just going to divide that by 0.66, and I get my concentration. So my molarity is 0.2479. Let's check sig figs. So 660 has 2 sig figs. That's why I wrote only 0.66, not 0.660. And 33.4 has 3 sig figs. So my final answer should have 2. So this is going to be 0.25, and my units are molar. Okay, and that's it. Let's look at one more. All right, for the last one, it says how many kilograms of lead 2 oxide are required to make 220 mils of a 0.75 molar solution. So remember, molarity is my moles of my solute, which is what I'm going to be solving for first, divided by my volume in liters. So I know my concentration is 0.75 molar. I'm solving for my moles, so that's going to be my X. And my volume is 220 mils. But keep in mind, I need that in liters. So what I'm going to do is I'm going to put milliliters on bottom, liters up top. 1 mil is 10 to the negative third liters. So this is going to be 0.22 liters is my volume. So I'm going to plug that in here, 0.22. So to solve for X, I'm going to take 0.75, and I'm going to cross multiply, so 0.75 over 1. So this is going to be 0.75 times 0.22, and that gives me 0.165. And then X times 1 gives me just X. So my number of moles here is 0.165, and my units are moles. Now, I'm not done yet because it asks how many kilograms. Okay, so let's now convert my moles of my solute. I first need to get into grams of my solute. Okay, so I'm going to put grams on top. Then we get out of grams and into kilograms. Okay. In order to do this conversion, though, I need to know the molar mass of my substance, and to know the molar mass of my substance, I need to know its formula. So let's work on that down here. Okay, I'm told I have lead 2 oxide. Well, lead 2 oxide means that lead has a 2+ charge. I know that oxygen is a 2- charge. So when I cross charges, Pb2O2 simply becomes, it reduces to just PbO. Okay, so Pb, lead, has a molar mass of 207.2. I'm going to add to that the molar mass of oxygen, 15.999, and the molar mass I get is 223.199. And that's for every 1 mole. Then I know that 1 kilogram is 10 to the third grams. So when I solve for this, I'm going to take 0.165, multiplied by the molar mass, then I'm going to divide by 1,000, and I get 0.0368. Okay. Now keep in mind that's unrounded. I want 2 sig figs for the 220 mils and 2 sig figs for the concentration. Okay, so 0.368 would round. I just want 2 sig figs, so this would round to 0.037 kilograms. Or if I wanted to put this into scientific notation, it would be 3.7 times 10 to the negative second kilograms. Okay, and that's my answer.